Morning, kids. Welcome to the math show today. What am I talking about? I don't even know. By the way, my name is Mr. Krause. I'm going to be Mr. Key for today. We are on 4.8. Oh my gosh, the last day of Unit 4. And then Unit 5 starts. And it just keeps going and going and going. By the way, all of these videos can be found at www.nk. That's Newman Krause. Infinity.com. I don't know what I was going to say. I was going to say something, but I don't remember what it was. So I'm just going to keep going. I don't know if I just haven't had enough coffee yet this morning. Thank you, Dunkin' Donuts, for helping me with my K-Cups this morning. Dunkin' Donut K-Cups. It is delicious. By the way, they're a sponsor. The only thing they sponsor me is caffeine. I don't get anything else. All right, let's get going. Let's talk about the difference between factoring an expression and solving an expression. That should be capitalized because that's huge. Anyway, let's factor a completely. Two sets of parentheses. X squared, X squared. This is plus, so they both got to be the same sign. In this case, they're both going to be negative. 9 and 5. So my answer for this one is x squared minus 5. Oh, thought I had a different answer. And x squared. Oh, wait, hold on. X squared minus 9. Whoa, let's back up the crazy train here, girlfriend. We can factor that, can keep going. X plus 3, x minus 3. So there's my answer for that one. That is fully factored. Done. Now let's take a look at what it means to be an equation. Well, we already factored it. We already know that it's x plus 3, x minus 3, x squared minus 5 equals 0. But we've got this little piece here at the end. And what that piece means is you have to give me a solution, not factors, but a solution. You have to keep going. You have to solve it. So I need to set this one equal to 0. I'm going to show you this, but I'm not going to do it very often during the thing. X plus 3 equals 0, and I end up with x equals negative 3. This one here, you're going to set this equal to 0. X minus 3 equals 0. You're going to end up with x equals positive 3. Over here, you're going to set this one equal to 0. X squared minus 5 equals 0. That's a little bit different. We're going to bring the 5 over. We get x squared equals 5. And now I have to take the square root. And when you take the square root, you put a plus or minus. So in this case, I get solutions. Negative 3, 3, and then plus or minus the square root of 5. So notice the difference, what our solutions look like. This one has roots or solutions or answers. This has factors. And you have to be able to, I can't tell you how many times a problem said, factor completely the following, and then this is what kids give us as answers. You know, there's no equal sign. You're not going to finish solving it. You're just done. You're just done. Factor and you're done. All right, kids. All right, to solve a polynomial equation using factoring. Get the equation equal to 0, factor completely, set each factor equal to 0, solve each value for x, write as a set. Now this part, is it mandatory? No, but man, it makes you look like a professional student. Write your answers in a set notation. So we're just going to keep going with some factoring here. We're going to take out an x squared. There is no GCF. X plus 6. Minus 4, x plus 6, equals 0. Two factors, x squared minus 4, x plus 6, equals 0. Factor completely. This is x plus 2, x minus 2, x plus 6, equals 0. But now that I have the equals part, I got to go one step further. I'm only going to do this once for you kids, and then I'm going to stop. So this is x plus 2 equals 0. I'm at this step right here. And then you're going to subtract 2. And I get x equals negative 2. I think at trig level, you should be able to do that, to go right there. So you should also be able to say that this is going to be x equals positive 2. and x equals negative 6. I'm hoping that you guys can figure that one out on your own. So I've got 3 answers in set notation, negative 6, negative 2, and 2. It also makes you look nice if you put them in numeric order. Don't have to, just makes you look good. First rule of factoring, take out the GCF. I'm going to take out a 4. I'm left with x to the 4th plus 10x squared minus 11 equals 0. 4x squared x squared. Oh, I'm going to end up doing some of these twice. All right, since this is an easy one, I'm not going through the split the middle and go crazy kind of thing. Multiply to negative 11, add up to 10. That's got to be positive 11 and negative 1. Well, that one's not done, so we got 4. Sorry, thought I had a brain cramp there for a second. X squared plus 11, x plus 1, x minus 1 equals 0. Now, these two are easy. These two over here are easy. This is x equals negative 1. You don't need to show any work on these. These ones are kind of simple. X equals positive 1. This one, however, not so much. Here, I can blow this up. I'll make sure you understand what I'm talking about here. So this one, not so much. So this one, we got to set x squared plus 11 equal to 0. Bring the 11 over, I get x squared equals negative 11. Take the square root of both sides. When you take the square root, you put a plus or minus. Now, that's not good enough to leave it as plus or minus the square root of negative 11. You know what the square root of the negative is. It's I. So this becomes x equals I square roots of 11. Oh, plus or minus. So let's write up our answers. Negative 1, 1 plus or minus I square roots of 11. Woo, we look so professional. All right. Okay, here we go. Problem number 3. Still got to set it equal to 0, so I'm going to bring this over. And it should go in the middle here. You should put these in standard form, so I'm going to subtract this 10x squared. Do you need to show this step? For some teachers, yes. For some teachers, no. My class, no. If you're smart and they go, oh, I'm going to bring that over, it gets a sign change. Just throw it over there. I mean, you're staying organized by doing this, and you're showing all your steps. But at the trig level, at the algebra 2 level, I got to change over to Common Core stuff. You should be able to move something from one side to the other, change the sign, and put it in the right place. I would say so. All right, let's factor. Again, this is an easy factoring, so I'm just going to show you one way. It's x squared and x squared. Multiply to 9, add up to 10. Pretty simple, right? Wait a second now. Those are both the difference of perfect squares. So this is going to give me x plus 1, x minus 1, x plus 3, x minus 3 equals 0. So I've got 4 answers. X equals negative 1, x equals positive 1, x equals negative 3, x equals positive 3. So negative 3, negative 1, 1, and 3. Again, you don't need to put those all necessarily in order. I didn't do on the last problem, but kind of looks nice. All right, so I'm going to bring this cube over. Now, a cube would go right in between here as well, and it's going to get a sign change. So 2x to the 5th minus 14x cubed plus 24x equals 0. Did I write equals 0 over here? By the way, you don't write equals 0, you're not maintaining an equation, which means you're making a mistake. So make sure you don't do that. Be smart. I don't know. I'll think of the word. Brain's not working this morning. I don't think I've had enough coffee. The GCF in this case is 2x. So I'm left with x to the 4th minus 7x squared plus 12 equals 0. Now I'm going to keep factoring. Leave the 2x here. Since it's easy factoring again, I'm just going to keep going. This is going to give me x squared and x squared. Let's see, multiply to 12 that add up to 7. You got it, minus 3, minus 4. We got dots here, difference of 2 squares. We got to keep going. Yeah, baby, I love factoring. It's so much fun, it's so much fun. I love it, love it, love it. X minus 2, difference of 2 squares. And now we're ready. So each piece needs to be set equal to 0, children. You can't just ignore the pieces. Now over here, where'd it go? I took out a 4, right? I ignored this 4 because this 4 can't be equal to 0. I mean, I could set 4 equal to 0, but that's not true. So it's not going to give me an answer. But down here, I did take out a GCF. So I have to set that equal to 0. 2x equals 0. Obviously, 2 times 0 is 0, but if you need to show work, divide by 2, I get x equals 0. Now think about it. If x was 0, if you plug a 0 in there, and you plug a 0 in there, and you plug a 0 in there, that'd be 0 plus 0 equals 0. Clearly, 0 is a solution. Anytime you take out a variable as a GCF, 0 will be a solution. So this one we have to set equal to 0. This is the hard one. X squared minus 3 equals 0. Bring the 3 over. X squared equals 3. Take the square root. And when you take the square root, you put a plus or minus. So this one gives me x equals plus or minus the square root of 3. This one gives me x equals negative 2. This one gives me x equals positive 2. Now let's see if we can get these in order. Negative radical 3. No. Negative 2. Negative 2. Negative radical 3. 0. Radical 3. And 2. That would be in order. Because the square root of 3 is like 1.7 something. I know you all knew that. You all knew that. Whatever. Hello. Hi, kids. You're so much fun. All right. Got 4 terms. Let's group. This first one I can take out an x to the 4th. I'm left with x squared minus 4. Ooh, dots. All right. Minus 9. Now we took out a negative 9, so I'm left with x squared minus 4. Again, remember, negative 9 times negative 4 is, in fact, positive 36. First set of parentheses is x squared minus 4. Dots. And whoa, wait a second, what do I got here? X to the 4th minus 9 equals 0. Dots again. Everywhere I see dots. I think I need help. I know I need help. X plus 2. X minus 2. X squared. X squared plus 3 and minus 3. Oh my goodness, we're going to end up with all kinds of cool answers. All right. Let's start with this one. X equals negative 2. X equals positive 2. Now these two, I got some work to do. Let's do this one first. X squared minus 3 equals 0. X squared equals 3. Take the square root. And when you take the square root, you got to remember to put a plus or minus. So on this one, I end up with x squared equals, oh, not x squared, just x. Gosh, it's so embarrassing when I make mistakes like that. X equals plus or minus radical 3. By the way, if that radical 3 can be simplified, you should. Wouldn't be very nice for your teacher in a problem like this to do that. But maybe they're trying to see who steps up to the game. All right, let's try this one. So this one is x squared plus 3 equals 0. We're going to bring the 3 over, so we end up with x squared equals negative 3. Come back in, take the square root of both sides. When you take the square root, you put a plus or minus. Gosh, that beat's got some serious rhythm. So x equals plus or minus. Now the square root of a negative, don't forget, is I. So this is I radical 3. All right, let's see if we can get these suckers in order. I don't even know, man. The heck with it. Let's just do it this way. Plus or minus 2. Plus or minus I square roots of 3. Comma. Plus or minus the square root of 3. That's good enough. All right, moving on. Wow, that was a lot. what do we got here? Let's set it equal to 0. Don't divide. You're going to start losing factors. You can't just divide by x cubed. That means you're going to lose factors. You need to set it equal to 0. 48x to the 5th minus 27x cubed equals 0. Divisibility rule for 3 says if you can add up the digits and that's divisible by 3, the number is divisible by 3. 4 and 8 is 12. 3 goes into 12. And clearly 3 goes into 27. So I'm going to take out a 3x cubed. And I'm left with 16x squared minus 9. Ooh, dots. Dots. I see dots everywhere. Everywhere I go, I see dots. So 3x cubed. Ding, ring, 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 equals 0. So 4x and 4x plus 3 and minus 3. All right, we're done almost. This one's going to give me x equals 0. Now, if you want to see it, you can see it. 3x cubed equals 0. X cubed equals 0 over 3, or x cubed is equal to 0. Take the cube root of both sides, you get x equals 0. But I just told you a few minutes ago, if you take out a variable as a GCF, 0 is going to be one of your answers. Let's think about it. If I plug in a 0 there, that side's 0, and if I plug in a 0 there, that side's 0. So 0 is going to be one of your solutions. Set this equal to 0. 4x plus 3 equals 0. 4x is equal to negative 3. X is equal to negative 3 over 4. Guess what this one's going to be? X equals positive 3 over 4. Oops, not 3 over 3. That's embarrassing. 3 over 4. I would hope eventually you get to the point where you can just skip to these steps. So, negative 3 over 4, goose egg, and 3 over 4. This one looks pretty easy, doesn't it? You're going to find this is probably one of the more difficult questions we're going to run into right here. But it looks pretty easy. But you should recognize this as x cubed plus 2 cubed, which means we have the sum of perfect cubes, which means it's going to be a binomial times a trinomial. Do you remember? Keep the sign, change it. Last one's always positive. The x and the 2 get dumped in here. The x squared goes here. The 2 squared goes here. And then in the middle is just the product of the 2. 2x. Well, this one's pretty easy. I just go x equals negative 2. Boom, done. This one, not so much. It's not factorable, but you still have to solve it. X squared minus 2x plus 4 equals 0. You can do it by quadratic formula, but I'm going to choose completing the square because you haven't seen it in a while. So we'll go, okay, x squared minus 2x plus square equals, bring the 4 over, negative 4 plus square. Now, if I add a square to one side, I got to add it to the other. Set of parentheses. That looks terrible. Squared. So x minus, now what is half of 2? Oh, 1. Square it, still 1. Add 1. So I get equals negative 3. Okay, we're almost done. Take the square root of both sides. When you take the square root, you put a plus or minus. So what I end up with here is x minus 1 equals plus or minus. Now the square root of negative 3, square root of negative is just I, square root of 3. Almost done. We got to bring the 1 over. So x equals, we're going to add it over. Remember, we're going to put it right here in front. 1 plus or minus I square roots of 3. So that one wasn't quite as easy as it looked. It started out looking like, oh man, this problem's going to be a joke. Boom. Shakalaka. It ain't a joke. It's not an easy question. So my 3 answers are negative 2 and 1 plus or minus I square roots of 3. Those are my 3 answers. This one over here looks rather simple until, oh man, that one looked like fun. Now, we already talked about 343, I believe yesterday, the day before, something like that. I don't remember when it was. It was sometime recently. 343 is really 7 cubed. So this whole thing is 7x cubed plus not 8. Don't be silly. This is 4 cubed equals 0. So we have the sum of perfect cubes again. Let's get those signs in. Copy over the sign, change it. Last one's always positive. All right, we're going to dump the two things in, 7x and 4. And then over here goes 7x, be careful, squared. So that's 49x squared. Are we out of our mind? Krause. Over here goes 4 squared. That's 16. And in the middle goes the product of the two, 28x. All equals 0. All right, so this one's easy. 7x plus 4 equals 0. 7x equals negative 4. X equals negative 4 over 7. Ka-ching. This one is a monster. I'm going to need my calculator for this. I don't even have my calculator up. I need my calculator. Even the great Mr. Krause. Oh, who said that? Nobody. Said no one ever. So what we're going to do is 49x squared minus 28x plus 16 equals 0. Clearly, I cannot use the completing the square because I need my leading coefficient to be 1. So the only really recourse here is the quadratic formula. A equals 49. B equals negative 28, C equals 16, and D equals... Wait, is somebody crying going, are you kidding me, Mr. Krause? Who the heck would give this problem? Your Algebra 2 teacher would, because you're not a baby anymore. Grow up, seriously. It's embarrassing. D is the discriminant. I should write that as capital D, but it doesn't matter. B squared minus 4A, what is that? AC. That's the discriminant. By the way, once this work's done, the problem's simplistic. I don't know what negative 28 squared is. I don't care about the negative because I know the negative will go away. So I'm just going to do 28 squared. And that's 784. So 784 minus 4 times 49 times 16. I'm going to type all of that in because if I try to do a piecemeal, I will mess that up bad. So minus 4 times 49 times, I don't even remember what the last number is, 16. Is that what I had? Oh, yeah. Equals negative 2,300. I hate you all. I really do. I hate you all. Look at that. Negative 2,352. You're like, Krause, you're crazy. Remember how I said a few minutes ago when all that work's done is the easy part's over? Oh, the hard part's over. I lied. I lied like a dog. So x equals, negative b is 28 over 2 times 49 plus or minus the square root of negative 2,352 all over 2 times 49. So now I get x equals 28 over, well, hold on. 2 goes into 28 14 times. At least I can do a little bit of that math. So, and wait, hold on. Let's back up the crazy train. 7 goes into both of these, so 7 goes in there twice. So that's really just 2 7s. By the way, you could have just put that in your calculator. I mean, just come over here and go 20, control division, 28 over, all right, gonna get to 20. 28 over 2 times 49. It'll pop up 2 7s for you if you want. But it's this thing that's going to cause us all kinds of problems. I don't know what the largest number that goes into. I don't even know if it does have a number, but I got to check to see if it's got a number. So I'm going to check 4. So 2,352 divided by 4. 4 goes in. I'm going to check another 4. So 588 divided by 4. 147. So, believe it or not, there's a perfect square that goes on. So far I could use 16. So let me go back. 2,352 divided by 16. I know at least 16 goes in because 1 4 went in, 1 4 went in. Now 49, or excuse me, 147 is divisible by, I believe, 49. So 16 and 49 both go in. What is 16 times, well, let's just do it that way. So I'm going to bring this off to the side. 2352 negative is equal to negative 16 times 49 times 3. All right, so let's see. What is the square root of 16? 4. What is the square root of 49? 7. So those make 28. But don't forget, I still got this negative here, so that's an I. All right, here we go. So we end up with 28I square roots of 3 all over, well, it turns out 98. Let's see what 28 over 98 is. 28 divided by 98 equals 32 over 7. What? 28 divided by 98. Oh, 2 sevens. Oh, that's 2 sevens too? Oh, okay. So I get, I just did it over there. 2 over 7 plus or minus 2I square roots of 3 all over 7. I told you I didn't like you. That, my friends, would be like a bonus on a test. Can you get to that point? Not a big bonus, but just a little bonus, maybe. All right. Okay, let's see what we're talking about. Using roots or zeros to graph polynomials. And really what I want you to be able to do is sketch a polynomial. Understand the behavior of the polynomial. And we can use zeros to understand that. So let's talk about this first one. Why this one is what it is. So if I graph this one, I think I'm going to get, there I am. Okay, so why did I say it has real roots? My roots are going to be x equals -1 and x equals 3. 2 real roots. It's a quadratic, so those are the only roots, so it's going to go through. It's got a positive leading coefficient, so it's going to point upward. So now where did I get this -3 from? Well, that's from +1 times -3. That would be, and I can do a quick sketch. Those really, if I can find the roots and I can find the y-intercept, I can create a pretty accurate graph over here. Roots, x equals 0, x equals 1, x equals 1. Oh, we have a bounce. In this case, we have a bounce. When it's a bounce like that, what it is it comes tangent. It becomes a tangent. Right? Tangent to the thing. I call it a bounce, but if you really want to know what it's called, it's a tangent to that line. That's why I call it tangent to the x-axis. And when you get into calculus, you need to start using terminology like that. So it's a double root. It bounces off the x-axis and comes back. It becomes tangent to the x-axis, comes back, goes through 0. Now, this is an accurate drawing of this. Now, had you drawn it like this, that would still be a sketch because, you knew that it had to go through 0. And because we had a double root, you knew that was a bounce or a tangent to the curve, so you knew it was only going to hit there once, not go through it, just hit it. Now this one I said do not cross the x-axis, and yet I drew it crossing the x-axis. What I mean by that is this. These two give us real roots. That means it's going to hit the x-axis or go through the x-axis twice, at 0 and at 4. But for the non-real or the imaginary roots, it will not hit the x-axis. So notice here, second degree polynomial, we hit twice. We hit third degree polynomial, we hit it twice, but one of them was a bounce. So here it hit it and bounced off, so that's hit and bounce off, sort of like that. That's 2 roots, but it's really just 1 root. But here, I have 2 real roots. It's going to go through the x-axis, and 2 imaginary roots, which means it's not going to cross the x-axis for those 2. It's positive leading coefficient, and the degree is 4. So this, how do I get to degree 4? That's x times x times x squared. That's degree 4. That's why they're both going up. You need to be able to put all of that stuff together in order to get the roots. Oh, by the way, how did I know these were imaginary roots? Well, okay, we've just done some work. You know you're going to end up with x squared equals -3, right? And then you take the square root of both sides, you get an I. So let's see if we can sketch. I think I asked you just to sketch based on the end behavior and the y-intercept. Well, the y-intercept is sitting right here. Oh, it's going to go through the origin. If I take out an x squared, I'm left with x minus 1. So, oh, I can't take out an x squared. I knew something was a little off there. I can only take out an x. I'm left take out an x. I'm left with x squared minus 1. If I factor that, I get x plus 1, x minus 1. So my roots are x equals 0, which is also going to be my y-intercept. X equals negative 1 and x equals positive 1. Notice I'm not going to go to my calculator. I'm just going to sketch this thing. This is the most important word right here. I don't want a table of values, and I want you to be able to give me a quick sketch of what this looks like, and you're going to be able to do that in class. So I know it's going through 1. I know it's going through negative 1, because I'll ask you to sketch this without a calculator. Now, it's an odd function with a positive leading coefficient. Now, you know odd functions are either going to look like this or they're going to look like this. Now, remember, if I connect the arrows and that's positive, or if I connect the arrows and that's negative, that tells you about your leading coefficient. I have a leading coefficient that's positive, so I know it's going to do this behavior. I know to the right here, it's going to go up. So I'm going to just put an up arrow here. And I know to the left here, it's going to go down. All right, let's just see. Now, these points, it has to go through. Ring, ring, ring. And something like that. Something like that. Notice it's got that positive slope to it. Well, this one's weird. I need the end behavior. I need the roots. I need the y-intercept. Let's figure out what degree it is. We got x, 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 and x, and they're all being multiplied. So that would give me an x to the 4th. So that's even. And that's positive x. There's no negative here. Positive, positive. So that's even with a leading coefficient that's positive. Now remember, with a leading coefficient that's positive, that means they're both going to be up. Because it's even, they're both going to go in the same direction. And because it's positive, they're both going to go up. So my roots, they're all the same. They're all the same. So that means I'm only going to have one root. It's going to be a quadruple root at x equals negative 2. Because if I solved each of these, that would give me negative 2, that would give me negative 2, that would give me negative 2, that would give me negative 2. So how do I find my y-intercept? Well, the y-intercept just comes from multiplying, just multiply the constants. Now, I can only do that because they're all being multiplied. So I'm going to multiply 2 times 2 times 2 times 2. Eventually, I would get 2 times 2 times 2 times 2, which is 16. So my y-intercept is 16. Now, I probably should create a scale here because I only have 10 by 10. So I'm going to say, okay, kids, every box, you can put this anywhere you want, every box is going to be 1 horizontally, but 2 vertically. So 2, 4, 6, 8, 10, 12, 14, 16. My y-intercept is negative 2. Or my x-intercept is negative 2. Now, it's an even function. The arrows are going to be posted up. So this is kind of going to look like a parabola. Got to go through that point, though. Something to that effect. There it is, kids. That's all she wrote. This next one looks like a lot of fun. Holy crap. Let's get the roots first. My roots are going to be x equals 1, x equals 2, x equals negative 3, and oh, look what we got here. We got a tangent or a bounce. X equals negative 4 and negative 4. So this is going to be a bounce. Now remember, we're sketching it, so we're not grabbing. You're not going to see me come over there and grab my calculator. We're going to do this on our own. Now I got to find that y-intercept. So we're going to multiply negative 1, negative 2, 3, 4, and 4. Well, 4 times 4 is 16. 16 times 3 is 48. 48 times negative 2 is negative 96 times negative 1 is positive 96. So my actual y-intercept is 96. Now, because this is a sketch, I probably don't necessarily need to come up with that negative 96. I can just show where it is. In fact, that's what I'm going to do. I'm only going to do on the x-axis. So we're going to put a negative 1 here. We got an x-intercept. Got a negative 2. We got a 3. And we got a 4. Now, it's a 1, 2, 3, 4, 5. It's an odd function. Now, what is the leading coefficient? X times X times X times X. The leading coefficient is positive. So leading coefficient is positive. That means that it's going to look like, hopefully I can show you, well, it's going to look like, I can do it over here, this. Now, because of all these roots, it's going to have some bumps, lots of bumps in there, and it's got to get up to 96. So I'm going to do this. I'm going to say this. Well, I'm going to say this is 96. So just put that there. That's the scale, 96. Okay. So now I know it's got to start down here. So I'm going to point down. Because it's positive, it's got to point down here. And I know after I'm done with this one, I got to point up. Because that would be an odd polynomial with a leading coefficient that's positive. Now I just got to sort of connect the dots. I got to go through this point. I got to go through this point. Whoa, 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 whoa. Let's back up the crazy train. Something's going on here. Ah, that's my problem. A little brain fart, kids. It wasn't positive 4, it's negative 4. What am I doing? Oh, and it's negative. Wait a second here. What am I doing? All right, kids, I hope you saw the mistake. Here's one of my roots. Here's one of my roots. At negative 3 is one of my roots, and negative 4 is one of my roots. Oh, my goodness, that was a mistake. Okay, but the end behavior is still the same. It's going to go up here. Apologize about that. I had my roots all backwards. I don't know what I was doing. I think I was reading these as opposed to reading what I actually wrote down will work. So I guess that's my mistake. Sorry. So watch what happens here. Don't do this just yet. If I go through this and I come back, if I have to come through that point up there, that's when I knew I made a mistake. I have to go through that point up there. In order to do so, I would have to come back through the x-axis. I can't do that because there's the most amount of roots I can have is 5. And I have 5. 1, 2, 3, 4, 5. I have 5 roots. And I don't have any other roots. So I can't do that. But remember what I just told you a few minutes ago. We have a tangent or a bounce. It's tangent. So it's going to come up to the x-axis, but it's not going to go through. It bounces off. Comes back down. Then goes back through. Goes up here. Then we're going to go down through this point. Back through this point and up there. Woo! So anytime you see graphically this, when it bounces off, you know that's a double root. At least a double root. Could be a quadruple or whatever root, but at least a double root. All right, when you bounce off like that. All right. All right, let's talk. Let's find our roots first. Let's talk about our roots. The easy ones are this one, x equals 2 and x equals 3. So I know I'm going through 2. I know I'm going through 3. This one's not so easy. This one's going to give me x squared equals negative 1 or x equals plus or minus the square root of negative 1. And the square root of negative 1 is just I. So x is equal to plus or minus I. So those are my other roots. My y-intercept is going to be 1 times negative 2 times negative 3. So my y-intercept is 6. It is an even function. How do I know it's an even? I've got an x squared times an x times an x. So that makes it an even function. It's actually a 4th degree function. And notice no x negative there. That's positive, and that's positive. So my leading coefficient is positive. Now, as soon as I know it's even leading coefficient positive, I know it looks like this. Now, I only have two real solutions, and it goes to the point positive 6. The other roots are imaginary, which means this is only going to cross the x-axis twice. So when I graph this thing, it's actually going to look like a parabola. It's going to come down, come down, come down. It's going to go through, come back through, and graph. And there it is. Now, based on that, if you saw that graph, you'd say that's a second-degree polynomial. You'd say that's a second-degree polynomial. It's a parabola, blah, blah, blah. Sometimes you don't know and you would not be able to create this unless I said, okay, look, it's got two real solutions and two imaginary solutions. And then you say, oh, that's a fourth-degree polynomial. Okay? But other than that, that's not a bad one. I think that's the last problem, right? Yay! All right, kids, hit the subscribe button, hit the like button, hit the Dunkin' Donuts. Let them know Mr. Krause rocks. Maybe they'll start providing me some... They're not going to give me anything, man. Anyway, I don't care. Goodbye, kids. Have fun. See ya. No, really, you got to go. I'm trying to find the stop button. There it is. I found it. Goodbye.